My name is Inayatullah Anar and my metric number is ES04223. So my part is formation of the sea. Seas are formed through the various geological processes, including the tectonic plate movements, volcanic activity, erosion, and others. Ocean bases can result from the separation of the continents or the sinking of portion of the Earth's crust. Additionally, factors like the sea level changes and glacial melting contribute to formation and shaping of seas over time. For instance, the Atlantic Ocean was formed as tectonic plate gradually pulled apart, leading to the creation of the Mid-Atlantic Ridge and the Atlantic Basin. So, by definition, the sea is the smaller part of the ocean where the ocean water and the land meet. So I found that in the world there are about 63 oceans all over the world, and 25 of them located in the Pacific Ocean, 16 of them in Atlantic Ocean, 11 in Indian, and another 11 in the Arctic Ocean. So the list also includes two sea lakes, the Caspian and the Aral. So they are known as the sea because of their large sizes, and the Dead Sea and the Sea of the Galilee, they are seas because of their historically established names. So the seas divided into three groups: the nearly enclosed seas, partly enclosed seas, and the hypersaline lakes. Nearly enclosed seas reach deeply into continents and are connected with the open oceans by narrow waterways called straits. Seas of this type include the Mediterranean Sea and the Baltic Sea. Such as seas are almost landlocked, they have a small range of tides. Some have no tides at all. Since there is little exchange of water between an enclosed sea and the open ocean, they may differ from each other like physically, chemically, and biologically. Among these landlocked seas in the Caspian Sea between Europe and Asia, the Volga River drains into the body of the water in the north. As a result, the northern part of the sea in Russia and Kazakhstan is almost a freshwater lake. So the southern part of the sea in Iran and Turkmenistan is much more saline. So, according to the degree of desolation and peculiarities of the hydrological regime, the seas are divided into three groups: inland, for example, Mediterranean Sea, marginal sea, and the interland sea. According to the geographical location, the Mediterranean seas are sometimes divided into intercontinental seas and intracontinental seas. From a geological point of view, modern seas are young formations. In outline, close to modern one, they were all defined in the Paleogene, Neogene time, and finally they took their shapes in the Anthropocene. So the deepest sea, for example, Mediterranean Sea, are formed in the place of the large faults on the Earth's crust, and shallow seas arose when the marginal parts of the continents were flooded by the water of the world ocean. So let's talk about the seabed. So seabed is the ocean floor. This is the term used to describe the top layer of the oceanic crust found at the bottom of the sea just above the mantle. So the crust is made of the rock sediment, which is developed through the continuous cycle. Magma from the innermost part of the earth seeps out and cools to create the sediment, and then eventually it pushes back down into the ground, and this cycle happens again. So oceans cover nearly three-quarters of the ocean surface, yet around 95% of them have not been explored because the marine environment is hostile for humans. Special equipment is needed for research on the floor because of the cold, high pressure, low oxygen atmosphere, and etc. The Deep Sea Challenger is a vessel created to withstand these environments. It can travel to the deepest part of the ocean located in the Mariana Trench. So scientists are learning more about the ocean floor every day. One way this is done through the bathymetry. So bathymetry is the measurement used to understand the depths of the water and study the ocean's floor shape. So bathymetric marks are used to create a picture of the underwater features. So here I put the picture of the ocean floor. So the seabed is the known as the ocean floor, located in the bottom of the sea. The structure of the seabed of the world ocean is determined by plate tectonics. So the most of the ocean is very deep, and the seabed is known as the abyssal plain. The spreading of the seabed scratches meet ocean ridges along the central line of the main ocean basins, where the seabed is slightly shallower than the surrounding abyssal plain. From the abyssal plain, the seabed rises up to the continents and becomes in the order from the depths to shallow water, the continent, elevation, slope, and shelf. The depths within the seabed itself, such as depths of the sediment core, is known as the depths below seabed. So the ecological environment of the seabed and the deepest water together is known as the habitat of the living creatures called benthics. So we know about the plate tectonics from the high school or from the first year of the university. So this is the theory about the how the Earth was created. But talking about the ocean, if the new crust form at the divergent boundaries, it means that somewhere else the crust must collapse. Otherwise, the Earth would increase in size. When two plates collide, one of them moves under the other. So it's called subduction. At the same time, the plate that appears at the bottom skins into the mantle. What happens on the surface above the subduction zone depends on the location of the plate boundaries, under the mainland, on the border of the mainland, or under the ocean. So if the subduction zone is located under the ocean crust, then a deep mid-ocean depression is formed as a result. An example of this can be the Mariana Trench. So here we can see where the Mariana Trench is located. It's between Japan and the Philippines in the Pacific Ocean. So the Mariana Trench is the deepest known place on our planet. It is located in the western Pacific Ocean near the Mariana Islands, after which it's actually got its name. So the depression of the ravine in the ocean floor is so the length is 2550 kilometers with an average width of 69 kilometers. According to the latest measurement, it was in 1940. The maximum depth of the Mariana Trench is 10,984 meters. The Mariana Trench was formed as a result of the collision of the two plates of the oceanic crust. When lithosphere plates collide, one pushes the another um, under the mantle. So when two pieces of bark enters, a deep trough form above the bend in the sinking bar. So the first measurement and discovery of the Mariana Trench were carried out in 1975 from the British three-masted corvette Challenger. The first human who dived into the bottom of the Mariana Trench was Navy Lieutenant Don Walsh on January 23rd, 1960, and the instrument recorded the depth of this Mariana Trench of 11,521 meters. Actually, nowadays we have a lot of ecological problems, and one of them is the water pollution. So, human impact on the seas and water bodies. The world ocean occupies more than 70% of the Earth's territory, and while the 40% of its water area is considered severely affected by human activities, which means it's polluted. Yeah. So marine debris is collected in the sea, on the shores, in bays, and in the center of the marine near surface current systems. The largest accumulation from garbage island or spots, such as the Great Pacific Garbage Patch. So the ocean is overflowing with plastic waste, which is found even more remote atolls in the deepest depressions. So, according to the various estimates, from 1 to 2.5 million tons of the plastic waste enters the ocean every year, and most of them comes from Asia and Africa's rivers.
Hi, my name is Hu Zhongyue. My matrix number is 218414. Let me introduce this part of seawater chemistry. There are many chemical components in seawater. I will mainly introduce the salinity, pH, and the essential minerals. The salinity of seawater refers to the concentration of dissolved salts in seawater, usually expressed in terms of the mass of dissolved salts per kilograms of seawater. The average salinity of seawater is about 35 grams per kilogram, which means that there are 35 grams of salt per kilogram of seawater. The salinity of seawater is not evenly distributed throughout the ocean and may vary in different sea areas. In and depth. Typically, salinity is affected by a variety of factors, including evaporation, rainfall estimate, freshwater input, and ocean circulation. In tropic seas near the equator, due to high temperatures and strong sunshine, evaporation uh, is more obvious, and the salinity salinity is relatively high. In polar regions, the the effect of melting ice and freshwater inputs may result in low salinity. Scientists commonly use salinity to study changes in the ocean environment, um, monitor ocean circulation, and understand the health of marine ecosystems. The pH value of seawater is affected by many factors, including dissolution of carbon dioxide, changes in seawater temperature, and so on. With the influence of global climate change and human activities, the pH value of seawater may change, which may have an impact on marine ecosystems. Over the past few decades, due to an increase in atmospheric carbon dioxide, part of the carbon dioxide has dissolved in seawater to form carbonic acid, causing seawater to become more acidic, a phenomenon known as ocean acidification. Actification. Scientists are watching this trend closely and working to understand its potential impact on marine ecosystems around the world. The pH of seawater is usually between 8 and 8.5, indicating that it is alkaline. pH is an indicator used to measure the acidity and alkalinity of a solution. The lower the value, the more acidic it is, and the higher the value, the more alkaline it is. Alkaline seawater helps maintain the stability of marine ecosystems. The ocean contains many essential minerals that are important for existence and health of life on Earth. Seawater contains a lot of salt, mainly stu- sodium chloride. This is a key component in maintaining the balance, balance of water inside and outside the organism. Seawater is rich in uh, mag- magnesium. Magnesium is essential for bones, function, and energy metabolism in organisms. Seawater also contains large amounts of calcium. This is important for the formation of the skeleton and the shells of marine life. Sulfur in seawater is a component of proteins and amino acid, acids, acids in living bodies, and is also involved in the energy's metabolism process in living bodies. Phosphorus is an important nutrient in seawater and plays a key role in plant growth and ecosystem balance. Although the concentration in seawater is low, air is an important trait element in living organisms and participate in physiological processes such as oxygen transport and cellular respiration. These measures are vital to the balance of marine ecosystems and the normal functions of organisms. They are they are constantly involved in the survival and development of life on Earth through the circular of seawater and the biological activities. That's all for this part about the seawater chemistry. Thank you.
So yes, carbon cycle is a part of biochemical cycle by which carbon is exchanged. So basically, carbon cycle is a process where the carbon compounds interchange that consists of the biosphere, geosphere, pedosphere, hydrosphere, and atmosphere on the Earth. So, for your information, carbon cycle, there are two types for the carbon cycle. The first one is the carbon cycle for the short term, and the carbon cycle for the long term. Alright, for the short term, carbon cycle, the carbon cycle for the short term occurs within a relatively short period of time. So it is named as such because it takes just a few days, months or years for the carbon to flow across the various carbon reservoirs. For the long term of carbon cycle, this type of carbon cycle takes 1,000 years to occur. The excess carbon from the short-term cycle is stored for a long time before they are released. So yes, the carbon cycle moves naturally through the ground, ocean, and sky in slow cycle over million years of years. So basically, carbon cycle has a few steps. So the first one is the plants will absorb the carbon dioxide from air to grow and decompose to release carbon dioxide. So next, the iron-rich dust is blown by winds into the oceans and stimulates the phytoplankton blooms. So next, the air and sea will exchange the carbon dioxide, and at the same time phytoplankton will take up the carbon dioxide to grow. Then the zooplankton eat phytoplankton and respire the carbon dioxide. So we have to know the product of the carbon dioxide. Some of the carbon sinks to the depth in the form of decaying biota and fecal pellets. Then only a small percentage of the sinking carbon reach the deep sea. A tiny fraction is buried in the seafloor sediments, and most of the carbon is recycled back to the surface 100 to 1,000 years later by the ocean circulation. And over millions of years, carbon is incorporated to rocks or turned into the hydrocarbons. And the last one is rocks are eventually uplifted into the land and weathered to release carbon to soils and the atmosphere. Basically, carbon cycle gives many benefits to us and also to the ecosystem. So carbon cycle is very important aspect to the survival of all life on the earth. From an environmental perspective, carbon provides insulation by trapping the sun's heat. From a biological perspective, carbon is the building block of life and forms the stable bonds with other elements that are necessary for our life. So yes, sea has many roles in carbon cycle. There are many of them. So the first one is the sea or the ocean holds about 50 times more carbon than the atmosphere. And the second one is the sea or the ocean accelerate the two-way carbon exchange between the ocean's surface waters and the atmosphere. And number three, oceans store carbon at the deep ocean depth. And number four is a giant carbon sink that used to absorb carbons. And number five, we have to know that sea suck about a quarter of the carbon dioxide that are released into the atmosphere. And the last one is the sea has phytoplankton that regulate that carbon dioxide. So basically we have to know that oceans play a particularly important role in the carbon cycle. Surface water exchange gases with the atmosphere, and the plant like phytoplankton living in the ocean that convert carbon dioxide into sugars that feed an ecosystem. So when the marine animals die, their bodies may sink to the depth, where the carbon that contained in the gas to soft back to the deep water, or small fraction settles to the seafloor where it's covered in sediment and locked away for centuries. So we have to know that such processes may initially create coal or oil deposits deep underground the ocean.
Okay, next we move to introduction of thermodynamics. Density in particular is an important property in ocean science because small spatial changes in density result in spatial variations in pressure at a given depth, which in turn drive the ocean circulation. Vary with the amount of heat and the amount of soft matter contained in the water, as well as the ambient pressure. Important states, variables measured for parcels of water in the ocean are therefore temperature, which is related to the heat content, salinity, which is related to the amount of dissolved matter, and the pressure. As you can see in the table below, it shows you a variable of ocean properties, thermodynamic, ocean range, and ocean level. In addition to controlling physical properties, the variation in space and time of temperature and salinity are also important water mass traces that can be used to map the ocean circulation. So, if we want to measure the ocean circulation, it is very important to know the temperature and salinity of the ocean. Okay. Density is usually calculated using a mathematical function of temperature, salinity, and pressure, sometimes called an equation of state. So for the temperature, salinity, and pressure, for these three, they are being called an equation of state. However, a new international standard for seawater density, as well as all other thermodynamic properties, has recently been developed. Okay, this new standard is called the Thermodynamic Equation of Seawater 2010. It is rely on other international standards that precisely define the state variables of temperature and salinity. it is standards thus play an important role in ocean science. Okay, in this slide, we state three thermodynamic properties of ocean. The first one is temperature. Okay, as a corollary to this definition, objects in contact with one another will tend toward thermal equilibrium by an exchange of heat between them. Thus, if we know the temperature of one object, which is called it a thermometer, as we know the thermometer have to measure something that contains water. Okay, so and it is in thermal equilibrium with water around it, which will occur after enough time has passed. We also know the temperature of the water. So after we measure the water, after we measure using the thermometer, we will know the immediately temperature of the water, for example. Okay, conversely, if water and a thermometer within it are at different temperatures, then there must be a flow of energy, which is heat, between the water and the thermometer. This gives us both a way of talking about energy and a way of measuring temperature using a known reference. The simplest way is to define two reference points, plus a method that can be used to interpolate between them. Okay, so a little bit history about these temperature properties. In 1742, Anders Celsius defined a temperature scale in which the freezing point of water at sea level pressure was taken as a lower reference point with a value of 0. So as we know, the freezing point of water is 0 degrees Celsius, with the difference between the freezing point and the boiling point also at the sea level pressure taken as 100 units, which is 100 degree, the water is boiled. Okay, so it is measured in terms of the change in volume of a fluid. Continue. A thermodynamic scale is thus implicitly reference to a lower limit of absolute zero, which is defined to be 0 K. K is Kelvin. The freezing point of water was chosen to be a second reference by numerically defining the temperature of the freezing point of water to be 273.15 Kelvin. The thermodynamic temperature of the boiling point is found to be 373.15 K. 100 units higher, 100 units difference. Okay, so that an interval of 1 K and 1 degree Celsius are identical. As we know, the temperature of 1 Kelvin and 1 degree Celsius are totally different. Okay, the current standard for temperature is the International Temperature Scale. Temperatures in the range of oceanographic interest are set by first, the triple point of mercury, defined to be negative 38.8344 degrees Celsius exactly. The second one, the triple point of pure water with a specified isotopic composition, defined to be 0.01 degrees Celsius or 273.16 K exactly. And the third one is the melting point of gallium. It is defined to be 29.7646 degrees Celsius. Although in situ temperature defined by IPS 90 is generally the quantity we measure, it is not the most useful variable for describing heat content itself. Two effects can cause problems. First, the energy required to change the temperature of seawater by a fixed amount. let's say 1 degree Celsius, it called the heat capacity, is itself a function of temperature and salinity. It takes about 5% less energy to heat average seawater by 1 degree Celsius than it does to heat the same mass of fresh water by 1 degree Celsius. The second one is the effects of pressure can act to change the in-situ temperature of water without changing the heat content. Squeezing typical seawater or air causes the temperature to rise. A pressure of 100 atmospheres or about 1000 dbar is enough to increase measured seawater temperatures by about 0.1 degrees Celsius. However, the temperature of near freezing fresh water actually falls as pressure increases. So, if the temperature of near almost freezing fresh water is actually falls as pressure increase. So if the pressure increase, the temperature of fresh water, which is near freezing, also increase. The second thermodynamic properties is salinity. Salinity is a measure of the saltiness of seawater, or more precisely the amount of dissolved matter within seawater. Operationally, dissolved matter is that which remains after passing the seawater through a very fine filter to remove particulate matter. The story is complex for two reasons. First, any useful definition of salinity contains approximations of some kind. These approximations are necessary because the dissolved matter in seawater is a complicated mixture of virtually every known element, and it is impossible to measure the complete composition of every water sample. Okay. The second one is subtle technical details of these approximations, which have undergone changes as more has been learned about seawater, are very important in practice. These details are important because the required measurement accuracy for salinity necessary to understand the ocean general circulation is extremely high. Most useful definitions of salinity are rooted in the well-known fact that the relative ratios of most of the important constituents of seawater are approximately constant in the ocean, which is the principle of constant proportions. So the principle of constant proportions tells us that the relative ratios of most of the important constituents of seawater are approximately constant in the ocean. Therefore, practical but approximate measures of the total dissolved content can be found by scaling measurements of a single property. Originally, the property most conveniently measured was the chlorinity or halide ion. Mainly, the halide ion are Cl- and Br-, which is chloride and chlorine and bromine concentration. Chlorinity was measured using a straightforward chemical titration and then convert to a measure of salinity using a simple linear function. However, almost all modern estimates of salinity rely on measurements of the electrical conductivity, or at high precision, on measurements of the ratio of the conductivity of a sample of seawater to the conductivity. Since the electrical conductivity of seawater is also highly temperature dependent and mildly pressure dependent, temperature and pressure must also be measured in this approach. The conversion from measured temperature, pressure, and conductivity to salinity is complex and non-linear. So basically, we know the electrical conductivity can conduct electric. Okay, so seawater is also highly temperature dependent. since the electrical conductivity of seawater like that, and it is also mildly pressure dependent. So these properties are very important to the ocean. Okay, so we already know the properties of thermodynamic, which is temperature and salinity. So we move to the most important thermodynamic properties, which is density. Okay, the most important thermodynamic property of seawater for studies of oceanic circulation is its density, as I said just now. Okay, density depends on heat content and salinity. Since seawater is not perfectly incompressible, it also varies slightly with pressure. Increase in density with pressure is a problem when trying to decide which of two water parcels in the ocean, initially at different depths, will be lighter than the other if they were brought together. This is because the pressure effects often result in the largest apparent differences. So, these properties are related to each other, and the density is the most important since the seawater is not perfectly incompressible, so it also depends on heat content and salinity. Okay, the density of warmer waters does not increase quite as much as the density of colder waters for the same change in pressure. Thus, two water parcels with different temperatures and salinities but the same density at the surface, with the same potential density, will in fact have slightly different densities at another depth, even if their heat content and salinity remain the same. So, if their heat content and salinity is same, they might have been slightly different densities at another depth. This is called the thermobaric effect in deep convection areas, which are places in the Labrador and Greenland seas, and in some locations around Antarctica, where surface water is cooled and eventually sinks to depth of several thousand meters. Okay, last but not least, for the density, which is the most important thermodynamic properties of the ocean. Okay, however, the shallower water mass is heavier than the deeper water mass only if both are brought to the surface. If both are brought to the ocean bottom, the shallower water mass is lighter than the deeper water mass, and one can conclude that the water column is stably stratified. Deciding which measure of density to use in oceanographic analysis can be challenging, and it is still an area of ongoing research by marine scientists and so on.
So now we have important roles between hydrosphere and lithosphere. So the first one is, for example, water can move through the lithosphere by dissolving minerals in the lithosphere. That's the first one. And the second one, we have to know that hydrosphere covers all the water present on the surface of the earth. And the third one, hydrosphere helps to regulate the temperature of the environment and also sustain various life forms. And the last one is water can also help to move spheric plates around by heating up rocks in one region and causing them to expand and become less dense. So yes, the hydrosphere and lithosphere are the important components of the earth. So these components tend to change due to the time and also to the other effects. The key difference that we have to know between hydrosphere and lithosphere is that the hydrosphere is made up of all water on the earth, whereas the lithosphere is the solid, the outermost layer of the Earth. Moreover, we have to know that the hydrosphere includes water and all the aqueous living organisms, while the lithosphere includes rocky materials, soil, and minerals. So, yes, these two has their own vital roles for our Earth.
Okay, so what is human impacts towards our marine? We have ocean acidification, climate change, fisheries, pollution, eutrophication, and oil spill. So for the ocean acidification is the increasing acidification of the oceans caused mainly by the uptake of carbon dioxide from the atmosphere. The rise in atmospheric carbon dioxide due to the burning of fossil fuels leads to more carbon dioxide dissolving in the ocean. When carbon dioxide dissolves in water, it forms hydrogen and carbonate ions. This in turn increases the acidity of the ocean and makes survival increasingly harder for microorganisms, shellfish, and other marine organisms that depend on calcium carbonate to form their shells. As we know, the animals which have shells, it is fact, it comes from calcium carbonate. So yeah, calcium carbonate is important for them. Okay, increasing acidity also has potential for other harm to marine organisms, such as depressing metabolic rates and immune responses in some organisms and causing chloral bleaching. Okay, next we move to climate change. In marine environments, microbial primary production contributes substantially to CO2 sequestration. Marine microorganisms also recycle nutrients to use in the marine food web and in the process release CO2 to the atmosphere. Microbial biomass and other organic matter, remnants of plants and animals are converted to fossil fuels over millions of years. By contrast, burning of fossil fuels liberates greenhouse gases in a small fraction of that time. Okay, so we move to the fishery. Fishery thing is about fishing activities. I mean, we always heard about overfishing activities. Okay, overfishing is occurring in 1/3 of world fish stocks. According to a 2018 report by the Food and Agriculture Organizations of the United Nations. In addition, industry observers believe illegal, unreported and unregulated fishing occurs in most fisheries and accounts for up to 30% of total catches in some important fisheries. Okay, in a phenomenon called fishing down the food web. It means the mean trophic level of world fisheries has declined because overfishing high trophic level fish. Next, pollution. I will explain one, which is marine pollution. Okay, marine pollution occurs when substances used or spread by humans, such as industrial, agricultural, and residential waste, particles, noise, excess carbon dioxide, or invasive organisms enter the ocean and cause harmful effects there. The majority of this waste, which is 80%, comes from land-based activity, although marine transportation significantly contributes as well. It is a combination of chemicals and trash, most of which comes from land sources and is washed or blown into the ocean. This pollution results in damage to the environment because it also can make the health of all organisms and economic structures worldwide will decrease, since most inputs come from land, either via the rivers, sewage, or the atmosphere. It means that continental shelves are more vulnerable. Okay, for the oil spill is about oil spill that we had shown maybe in river, in water or ocean like that. Okay, so for the oil spill is release of a liquid petroleum hydrocarbon into the environment, especially the marine ecosystem, due to human activity, and is a form of pollution. The term is usually given to marine oil spills where oil is released into the ocean or coastal waters. Sadly, oil spills still occur until now. It is coating beaches, sinking to smooth the ocean plant life, and killing a wide variety of birds, fish, and sea mammals. From light pollution and oil spills to microplastics and sea level rise, our impact on Earth ocean is significant. Okay, so that's all for human impacts on the marine environment.
Assalamualaikum. My name is Muhammad Fahmi Aizad bin Abdul Wahab. My metric number is 223,474, and my part is importance of the sea. First one, importance of the sea in hydrosphere. Water cycle. The sea is a primary driver of the water cycle. Through processes like evaporation, precipitation, and runoff, the sea interacts with the atmosphere, redistributing water across the globe. Second, salinity and density. The salinity of seawater affects its density. This density variation, especially in combination with temperature, drive ocean current and play a role in regulating Earth's climate. Third one is habitat. The marine environment is a significant part of the hydrosphere, supporting a vast array of aquatic life, from microorganisms to large marine mammals. In hydrosphere, oceans cover more than 70% of Earth's surface, making them the biggest part of the hydrosphere. The hydrosphere is simply the total of all the water in Earth's atmosphere. A hydrosphere is the total amount of water on a planet. The ocean's vital function in maintaining Earth's warmth is one way that is influence weather and climate. The ocean absorbs most of the solar energy, especially in the tropical water near the equator, where it functions as a giant heat-retaining solar panel. Additionally, some sunlight is absorbed by land, and after sunset, the atmosphere helps hold on the heat that would otherwise radiate fast into space. In addition to storing solar energy, the ocean aids in the global distribution of heat. Evaporation is the process of water molecules freely exchanging with the air when heated. The continual evaporation of ocean water raises the surrounding air warmth and humidity, causing rain and storms that are subsequently delivered by trade wind. As a matter of fact, practically all rain that falls on land originates in the sea, because heat absorption and ocean evaporation are strongest in the tropic. This region experiences very high level of precipitation. Outside of Earth equatorial area, weather patterns are driven largely by ocean current. Current are movement of ocean water in the continuous flow, created largely by surface winds but also partly by temperature and salinity gradients, Earth's rotation, and tide. Major current systems typically flow clockwise in the northern hemisphere and counterclockwise in the southern hemisphere in circular pattern that often trace the coastline. Ocean currents act much like a conveyor belt, transporting warm water and precipitation from the equator toward the pole and cold water from the poles back to the tropic. Thus, ocean currents regulate global climate, helping to counteract the uneven distribution of solar radiation or solar energy reaching Earth's surface without current in the ocean. Regional temperature will be more extreme, super hot at the equator and frigid toward the pole, and much less of Earth's land will be habitable. The importance of sea in lithosphere. First one is erosion and deposition. The sea erodes coastline through wave action, shaping the lithosphere over time. This leads to the formation of various coastal landforms such as cliff, beaches, and sea cave. Second is sediment transport. Ocean transport and deposit sediment, contributing to the formation of sedimentary rock over geologic timescale. These processes are fundamental to the evolution of the lithosphere. Third one is tectonic activity. The ocean play role in tectonic processes. Subduction zone, where oceanic plates dive beneath continental plates, are key regions of tectonic activity that contribute to the shaping of the lithosphere. In lithosphere, the lithosphere is the solid outer part of the Earth. It includes the brittle upper portion of the mantle as well as the crust, which is the outermost layer of the planet. There are two types of lithosphere. There are oceanic lithosphere and continental lithosphere. Oceanic lithosphere is slightly denser. The oceanic lithosphere includes oceanic crust, which makes up the sea floor. The lithosphere is divided into huge slabs called tectonic plates. The heat from the mantle makes the rock at the bottom of the lithosphere slightly elastic. This allows the plate to move. The movement of this plate is known as plate tectonic. Most tectonic activity take place at the boundaries of this plate, where they collide, tear apart, or slide against each other. Tectonic activity is responsible for many geologic events. Earthquakes, volcanoes, mountains, and deep ocean trench can all form this way. Sea level rising can affect the lithosphere in disastrous ways, depending on how quickly the sea level rises. First, any sea level rising that maintains a higher sea level will decrease the amount of land that is found above sea level, creating a habitable land loss. Importance of sea to produce lithosphere under seafloor process. Oceanic lithosphere forms at mid-ocean ridge where hot magma upwell and then cools to form plates. As the material moves away from the spreading center, as the plate cools, heat flow decreases and the sea floor deepens. However, only shallow, which is less than 1 kilometer, measurements of lithospheric temperature are possible. Hence, the two primary data set used to constrain models for the variation in lithospheric temperature, with HR seafloor depth and heat flow The depth corrected for sediment load depend on the temperature integrated over the lithospheric thickness. The heat flow is proportional to the temperature gradient. Initially, seafloor depth rapidly increased with the average increases relative to the ridge crest, proportional to the square root of the crustal age. However, for age greater than about 50 to 70 million years ago, the average increase in depth is lower and the curve is said to flatten. Mean heat flow also decreases rapidly away from the ridge crest, with value approximately proportional to the inverse of the square root of the age. But after about 50 million years ago, this curve also flattened. Last but not least is the conclusion of our presentation, Group 2. Firstly, formation of sea. Seas are formed through various geological processes, including tectonic activity and erosion. Ocean basin can result from the separation of continent or sinking of portion of the earth crust. Composition of sea. Seawater is mainly composed of water, more than 66.5%, inorganic salt about 3.5%, organic matter, and suspended matter. From the perspective of the chemical composition, solute in seawater can also be subdivided into nutrient, gases, trace element, and organic compound. Next is roles within hydrosphere and lithosphere. Water can move through the lithosphere by dissolving minerals in the lithosphere. Water can also help to move the lithospheric plate around. Hydrosphere cover all the water present on the surface of Earth. Hydrosphere helps to regulate the temperature. Lastly, the importance of sea. In hydrosphere, water cycle, salinity and density, and habitat. Lithosphere, erosion and deposition, sediment transport, and tectonic activity. So that's it for our presentation. Thank you.